Hi, my name is Gu Kai Han, and I'm the group leader for this group. So our group, we are doing machine learning based expert system for credit risk assessment, which is to assess whether to accept or deny the loan application of a particular applicant. And we have selected and used this dataset, which is German credit dataset, and we got it from Kaggle. This dataset is also used by two of the existing works in our project. And to begin with this project, we carried out data exploration and data understanding. And we have also carried out data preprocessing, which we check and identify the missing values in our dataset. And there is no missing values. We have identified correlated feature. We have also carried out data splitting, which we split 80% of the data into training and 20% of the data into testing. And in this data set, it is actually imbalanced because we can see that the number of good credit risks is higher than the number of bad credit risks. So we applied smooth technique to balance out the data set. And after applying the smooth technique, we can see that the minority class, which is the bad credit risk, it is now increased to become the same as the good credit risk. So now the data samples are ready and we will now train our machine learning models. So to implement the machine learning expert system, we selected 8 machine learning models. We trained them on the resampled data and evaluate their results. The model used in our project is random forest, decision tree, artificial neural network, and boosting algorithms such as XGBoost, CatBoost, LightGBM, knife Bayes, and graph convolutional network. So we have also carried out enhancement to 8 of these machine learning models. We have carried out hyperparameter tuning to tune the models. And these are the accuracy for each of the machine learning models after we have carried out the tuning. We will focus mainly on the accuracy since it is the main metric that we consider in this project. So now I'll begin with random forest. It achieved the highest accuracy among 8 of these machine learning models. It has the accuracy of 0.8 after tuning, followed by decision tree 0.79, followed by artificial neural network also 0.79, XGBoost also 0.79, CatBoost also 0.79. For LightGBM, it is 0.77. For knife Bayes after tuning, it is 0.72. And lastly, for graph convolutional network, it is the lowest, which is 0.6. And these are the accuracy of 8 of these machine learning models after we have tuned them. And since random forest has the highest accuracy, we select random forest to be implemented in our expert system.
Hi sir, I'm Tan Chun Sen. So now I'll continue with the procedures we have done after we select the best model. So we already decided to use random forest since it is the best model. It achieved the best performance among the other machine learning models. So what we do next is we want to use this random forest to generate our production rules for our expert system. So first we import this library, export text, to get the production rules from random forest. So in the code here, we also label that we only want the production rules from first 5 trees. Okay, so I just run this code. So this will be the production rules for the 5 tree generated from random forest based on our dataset, German credit data. So you can see all the features are here. So these are the production rules for first tree. and also we will have the production rules for second tree, and then continue with until the fifth tree. So after that, we hope that these rules will be more human readable, which means easier for us, for people to read it or understand it. So we come up with this code to convert from this into if then format, which means we can understand it easier. So I just run this code. So as you can see, the format already changed from this tree into if then format. So if the output if is with this kind of format, of course we are easier to read it and understand it. So also same has the production rules from first tree and then until the fifth tree. So what we do next is we plot the feature importance chart to know that which features takes the most important to our target variable. So this will be the chart. Then after that, I will demonstrate the our expert system from the rules generated just now from random forest. So I just run this code. So this will be the interface for our expert system for our credit risk prediction expert system. So as you can see, we need to fill in all these blank fields. Okay, so now I will demonstrate a wrong example first, which means because for all these fields we need to key in with integer values. So if any one of the columns, any one of the fields is any data type other than integer, the system will not function, or it will come out with error. It will tell the user that that field is wrong. You must put integer. So if I put any number, or sorry, I mean any alphabets. So I then, if you want to predict the credit risk, you just click this button, and then it will tell the user that, oh, error, invalid literal for integer with base 10. Because this is not integer, so we cannot predict the outcome. So let's say I change to a proper value. So I want to predict, so I just click this button, and it will tell the user the probability of good credit is 70.72%, and probability of bad credit is 29.28%. So the reason why we use this kind of outcome instead of keep straight away tell the user that, oh, this is a good credit risk, is because we want our system is just a act as just a decision support system, which means that we provide the result for the user, and with all this probability we let the user decide, as we let the user think themselves whether this credit risk is good or bad. So if I can try another example. If I want to try another example, I just click this reset fields, and then all the fields and the prediction outcome will be empty. So same, I just key in another example again. So you tell the user that, oh, this is not really a good credit risk, it's more to bad credit. So the user just think themselves, they know that, oh, their credit risk is bad. So that's all from me. Thank you.